right. Our final talk before the conference State of the Union, which I'm sure everyone's excited for. Swimming with the Sharks, IR Cubed by Nathan Case and Alon. Quick shout out to our sponsor, NTT VC. They're an independent venture firm formed in collaboration with NTT, leveraging a unique strategy and deep industry network. NTT-VC unlocks doors to relationships that can help founders and startups reach global scale. We also partner with first-time founders to launch startups. With that said, go ahead.
So as we're going through this, a lot of the stuff that I've done in the past centers around incident response, both for myself, companies that I worked for, or cloud providers, AWS in particular, working with AWS, the DoD, and because of that, I've seen all sorts of crazy stuff. As we get into what we're talking about today, it became apparent to me that when we got into Kubernetes, the ability to do things like packet capture, memory dumps, and disk copy or disk cloning kind of got a little awkward. So that's kind of what today's talk is about. And as we talk about this, the first thing we're going to talk about is incident response. I don't know how many of you actually have done incident response or do incident response as a day job. So let's do this. How many people are IR geeks? Cool. All right, so lots of us love punishment. That's neat. So we've all seen this before, NIST cybersecurity plan. This is kind of the highest level of abstraction that NIST gives us. This concept of what are the different stages of a cybersecurity plan. Today we're going to talk about detecting things, we're going to talk about responding to things, and we're actually going to talk a little bit about identifying things. So the first point here to talk to all of the people who don't do IR that are here for this talk is do no harm. When you do incident response, it can be very often a gut level response when you see a bad thing to simply yank the cables out of the wall and shut the network down. How many people have shut the network down? That's a wonderful moment when you get to yank the power cable out of the wall. The reality, however, is that as we talk about a lot of the things that we do in a cloud, as we talk about things that happen in a large data center, the APIs that we are given that allow different pieces, parts to communicate together can often be pulled or can often be yanked. Or for instance, Kubernetes clusters can be destroyed relatively easily. And what that does is it destroys all of the forensics data and all of the data that we would use as incident responders to evaluate what was actually going wrong in the system to begin with. So initially, this is the way that NIST would like you to understand that incident response works. Now, we can all agree that this is not actually how incident response goes. It's never this simple. It really is a little bit more like this. Whoops, there's a slide missing. There we go. It's a little bit more like this, where it's a little bit more chaotic. We have these things that happened that then drive us back into detection analysis and then evaluate whether we actually do really have containment. And because of that, we've got to figure out where and when we're going to utilize tools and how we're going to utilize those tools in such a way as to get the information we need to evaluate whether we actually have an attacker. To be fair, sometimes we don't. Sometimes it's just an internal threat that we didn't realize we had. Sometimes it actually is an attacker, and that attacker needs to be eradicated and removed. Now, in this talk, we're mostly going to talk a little bit about this active defense portion of incident response. This is the portion of your security plan that deals with how you've evaluated, how you've planned for an attacker inside of things in your environment. That means you're trying to get rid of them, you're trying to identify their actions, you're trying to identify the bad things they're doing, take stock of that, and then begin to get ready to get rid of them. Now, when we had written this talk originally, I had really hoped that we could give you a memory dump and a physical disk capture and a PCAP, and that may have been a little bit aggressive. We got to the point where we were able to give you a PCAP, at very least, and we've got detection rules that we're very comfortable with. We actually also have some physical disk capture that we've got the ability to do in AWS through SSM, and I'll show that at the very end. Also, we've got a couple of other libraries that we're going to show you at the end, but to be fair, in 30 minutes, we didn't have enough to show you how to do the entire pull. So as we go into this, we need to understand the system as a whole. Kubernetes can be a little bit awkward sometimes. So one of the things that comes up as a security person, as an incident responder, as we begin to look at incident response, is how we're going to actually document the system that we're getting dropped into. Now, I assume many of you actually do incident response with a singular company. Do we have any incident response consultants that get dropped into issues on a day-to-day basis? So that's what I used to do for AWS. They would literally pull me into a totally unknown situation, drop me in, and the first thing I would have to do is document and understand what was going on. And the first thing that would come out of that documentation usually was segmenting the network, so I could evaluate portions of the network one at a time. And that came to PCAPs. And what is the tool that we all use to look at PCAPs? Wireshark. Now, we would also do memory dumps and disk snapshots, but today let's just focus on that PCAP. Who's actually used Wireshark in AWS? Anybody tried Wireshark in AWS? Do you know what it does? Nothing. Do you know why? So in AWS, what happens is you have one ENI talking to another ENI, and those ENIs are only able to speak to each other. But it's not actually a normal network structure like you would have with a switch or a hub that you're probably used to at home. It actually allows you to talk directly to 2 points. So when we get into Kubernetes and we get into cloud and we start talking about how that interaction works, the issue is that there's no way for you to see outside of the 2 points that you have. So today what we're going to do is a bit of a magic trick that allows us to see considerably more of that network connection, more of that network connectivity, and actually allows us to do what I would consider a more meaningful capture of the pieces in the cloud. So as we think about this, this is really the portion where we're establishing control, segmenting that data, and then it allows us to also be able to build a safe area in this system. And the reason for that is we're actually able to go ahead and see the portion of stuff that is bad and the portion of stuff that is good. And Alon will be happy enough to show us that here in a moment. We're also going to go ahead and build some automated detection bits at the end.
If you say so.
If I say so, we'll try it on stage. And we'll see how that works for everyone. Now, the goals, as always, need to be restated just so we're all very clear. We need to correct or remove attackers, right? We understand that? And before we go into the demos, I want to make very clear that's what we're going to be trying to do here. We're also going to correct any failed internal actions. So if we have a failed pipeline, if we have something that's just wrong, not actually an attacker, maybe it was the new hire that you just have down the hall. Jimmy, the fun new guy, is deciding to like blow away the entire Kubernetes cluster. That would be one of those things. And we have to make sure that there are no current, I take it we know a Jimmy. We also have to make sure that there are no current attackers in the system. So that brings us to Kubernetes and what's going to happen in Kubernetes. I thought this was funny. I hope you all think it's funny. Get it? Who's Kate? Kate's? Haha. All right, maybe it's not funny. So, networking the weird.
You missed the Fargate thing also.
Oh, we did miss the Fargate.
No, it was there.
Oh, it was. Yeah, that's true. Thank you. That's what I was really looking for.
Okay, hi everyone. Alon Girmonsky. I'm a co-creator of a tool named KubeShark. Throughout the past, 5 to 6 years, me and my team, we've been very busy understanding Kubernetes, its challenges, and hopefully coming up with a solution for traffic observability. But before we dive into observability, let's understand why should we care? What's different in this Kubernetes beast that kind of make it a different environment than what you would know, I don't know, 5, 10 years ago with normal cloud computing. So just by raise of a hand, who's dealing with Kubernetes here in this room? Okay, that's a decent number. So maybe what I'm about to say won't come as a surprise, but it's good to put some numbers so we understand the complexity. First, Kubernetes is emerging as the operating system of the cloud, right? And again, you should know, probably that won't come as a surprise, that it introduces a set of new complexities, mostly due to its architecture that is highly distributed and dynamic. Just to put some numbers, an average organization may end up managing 5,000 pods across 10 or more clusters or 90 nodes. That's complex, and everything is being orchestrated by Kubernetes. Now, Kubernetes is an application infrastructure. I guess those of you who use Kubernetes do not use it to host your email server or Slack or something. It's mostly, if not completely the application, making its network the largest application hub where all business logic transactions are executing. Everything's happening there. Okay, and that network harbors evidence for security threats and performance culprits. Yet again, its dynamic and distributed nature makes it a blind spot. Thanks. So, again, those of you who are doing incident response, specifically those who have used Wireshark in the past, can probably value being able to simply see what's going on in real time. Okay, and this is KubeShark. KubeShark provides real time, identity aware, and we'll touch that in a second. Well, what does that mean? Cluster wide, protocol level visibility. Think Wireshark, if you've seen the tool, if you've used the tool, only reinvented for Kubernetes. With KubeShark, you can start seeing traffic, real-time traffic across the cluster, no matter the size of it. Let's assume you are parachuted into a Kubernetes cluster with, let's say, 200 nodes. A lot's going on inside, probably exponentially bigger than anything that is not Kubernetes. You can start seeing traffic in a matter of a few minutes without requiring many of the acronyms and pieces of technologies we heard in the past, like CNI, proxy, service mesh, sidecar, all the stuff that alter your architecture. So with KubeShark, you parachute it in, and in a couple of minutes, you start seeing all the traffic that goes on under the cover. It uses eBPF, BPF, and Kubernetes API, and probably you ask yourself, what are these acronyms? I'm gonna touch on that. But I'm not that good in slides. Hopefully, a live demo will speak louder than words. First, before actually going into the tool, okay, it's also about the installation. Again, incident response, it's different than APM or broad observability. You're parachuted in a matter of minutes. You need to understand what's going on to get enough insights to actually do something about it, right? KubeShark provides two methods of installation. One is long-lasting. It's kind of for the DevOps and the SRE to do across for the entire organization. One is on-demand, lightweight, and again, as said, in a couple of minutes, you see everything with minimum attack surface change. So this is where kind of I'm moving towards.
Now, while he gets that set up, we all understand that you shouldn't just go ahead and curl shell to root, right? we get that? Okay. This is more of a, hey, this is how we test this, and this is one of the things that happens. Ideally, if you're doing this in an actual incident, you've prepped this and you have this all set up.
Yeah. Give me one sec.
Please have your own repo. Please don't curl from the GitHub.
Okay. Live demo. Okay, here's what I wanted to show. Probably so small no one sees.
And we're done.
Yeah. Okay. KubeShark, basically to install KubeShark, and I won't do it here. I will show the maybe the video we prepared. Make use of it. Okay, here we go. So I'm in a cluster and I'm using a shell script, right, to download a file, okay? And I'll explain what it means when it happens. What does agentless installation stands for? Okay. If I have an application with 100 nodes and I want to see what's going on, usually, traditionally, I would need to install an agent across each and every node. That can be not only a cumbersome activity, but one that requires procedures and what have you, and it will take time. Okay? An agentless installation is basically asking Kubernetes on demand to deploy certain containers where they are needed. For example, at the control plane, or when nodes are being launched and terminated, you may want to have containers deployed at the daemon set level of those nodes. Okay? So this is how it's done in KubeShark. It's basically you're downloading a utility, right? A 50 megabyte binary utility that is capable of communicating with Kubernetes API and request the deployment of these containers in real time. So basically, from the point of view where the communication starts, from the point of time when the communication starts with Kubernetes API to the point where the containers are deployed, it takes roughly 2 minutes, no matter the size of the cluster. So let's kind of continue this. So until now, it was basically the download of the single binary file. The file is, by the way, open source, so you know exactly what's inside. This is the file actually running, communicating with Kubernetes API. And this is the real true-to-time recording. Let's say 30 seconds passed. You see a dashboard that goes inside your Kubernetes clusters, and you start seeing traffic, streaming traffic at the dashboard. Now, and I'm going to show KubeShark in a second, so you'll see everything. But what you see now is basically the difference between not having KubeShark and having KubeShark. It's the single, I'm going to use the slide for that. Okay. It's a single namespace, right, with, as said, 2 containers at the control plane level and 1 container at the node level. And again, that's consider EKS Fargate, for example. Okay, I'm not sure how many of you are using AWS for your Kubernetes. It's very common. With EKS Fargate, nodes are launched on demand. Right? You can start with 2 nodes, end up with 200 nodes, scale down again to 2 nodes. Right? So on demand, the worker container will be deployed at the daemon set at the node level. Okay? So you have 1 namespace to limit the blast radius, and it can be also an existing namespace. Okay, so that was kind of the installation. The installation is a couple of minutes, agent-less installation, communicating with Kubernetes API with minimal attack surface change. When I mentioned the terms BPF, eBPF, and Kubernetes API, so as said earlier, across 200 nodes and I don't know how many pods, right? Kubernetes orchestrates the launch and termination of each and every pod. That can be very hectic inside, and it's very hard to track what's going on. Like, for example, which pod launched where and communicating with what other pod that lives somewhere else. So for that, we use, as said, 3 layers. BPF is a very old kind of, it's the buffer that is responsible for the capturing the network payload. It helps us to capture the traffic and present it. eBPF is a relatively new technology that enables probing the operating system in a secure fashion. And again, the Kubernetes API that keeps a log of for example, the IP to identity resolution. If you have an IP traffic with certain IP and you want to know what was the service that was using the IP at the time, only Kubernetes API knows that. So we constantly monitor these 3 layers to come up with kind of everything that goes on inside Kubernetes. So now for the live demo. again, assume you are parachuted into a Kubernetes cluster and something goes wrong there. You use a set of observability tools to start going deep, right? Use your IPM system, you use KubeShark, you use Wireshark. I'm going to show all that stuff in a second. So let's really hope that the internet will allow me to show it live. Okay. So I'm using my APM system to see what's going on. I have a lot of dashboards, many dashboards. And then I know that some service is acting weird, but I really want to see what's going on inside. What does that service does? Okay. So in this case, I'm pressing traffic to see the traffic that goes on. And voila, this is the window of KubeShark opens specifically for a certain service that I'm now querying. Okay, and what do we see here? Now this is real time. Everything's happening. I have an EKS cluster running somewhere with Datadog agent installed there, and I saw some service acting weird. I pressed. I'm seeing traffic in real time. Okay, here, in the browser level, no kubectl access, no permission, no weird permissions. I'm seeing everything. I can simply stop the streaming, and this is a single service traffic, both DNS and HTTP, and I can go in and see all the way to the payload. Okay, if I look at the entire thing, if I want to see, for example, who this service communicates with, I have some more kind of service dependency mapping, but I think you kind of get the picture. This is a single service. If I want to see everything, I see everything. Okay, no, not limiting the specific service. So, and if you see this, you basically, and you know Wireshark, you basically see the resemblance. The only thing is the traffic capture is automated across all of the pods, those who exist and those who are not yet there, and those that will terminate. Also, the capture will get terminated there.
Can you go ahead and bring up the service map? So as we look at this and we think about what happens in cloud, and we think about cloud incident response, one of the things that comes up is what happens if I don't actually have control plane access? What if I'm using Fargate? What if I'm using something that's outside of my control? The beauty part about this is this works in Fargate. What you're looking at now is in Fargate and in EKS. So the ability to do this live on stage is kind of cool. But keep in mind, this is we saw it live. What was it? He said 2 minutes, but I think he really meant more like 20 seconds, honestly, as we looked at how quickly that installed. And the intent is, as an incident responder that needs tools to do a cool thing, one of the things that you have in your tool belt that frankly I didn't know before we started working on this, was the ability to go ahead and inject something like this into a namespace and then just immediately grab traffic from the entire cluster. So if I wanted to, I could grab subsets, or I could grab the whole thing, regardless of whether my Kubernetes cluster was on Azure, AWS, or in Fargate, or even a mix of the three.
Exactly. And we're constantly touching the Fargate thing because there's Kubernetes on-prem, where it's a beast, but still within your control. Also, the nodes are within your control. Then there is EKS, and then there's EKS Fargate. It's kind of, it's an infrastructure. You don't know how it will behave in a couple of minutes from now or later. Okay. So that's basically half of the value proposition here. It's kind of visibility. If I want real-time, cluster-wide, protocol-level visibility, I have it, right? No matter the size of the cluster, no matter how dynamic it is. But I cannot always be there, right, to actually see the problem, right? I want to be in a position where if I know how to define the problem, or let's say a certain suspicious network behavior, then maybe KubeShark will monitor traffic and then detect the network behavior, capture a pickup, so I can then analyze the pickup offline. Okay, so yeah, luckily that happens. So this is detection engineering, right? Not only visibility, once we gain access to all the traffic everywhere, we can also start querying the traffic in real time and triggering actions that can help us figuring out what's wrong. And, you know, okay. So with KubeShark come hooks and scripts that enable us to basically, again, as said, define situations and then trigger actions. What I'm about to show now is I'm going to find in KubeShark, I see some red. So for example, I'm going to add this. So as you can see, I defined a certain behavior. Like if the request path equals something, we'll do it regular expression. Right. Hopefully, meaning I always love live demos, but hopefully I'm not doing me wrong. Okay, so I'm trying this, and let's see if it was successful. Yeah. Okay. So I was able to filter out specific network behavior. I'm going to copy this. I'm going to go to the scripting section, and I'm going to put the behavior here. Done that. Activate and save. Okay. What happens now? So everything's running. Okay. And behind the scene, so that suspicious network behavior was actually detected, and I in all likelihood, I got a few Slack messages, right? And in these Slack messages, what am I seeing? I'm seeing the problem, a description of the problem. I'm seeing information about everything that KubeShark knows about what just happened in terms of the API information and the Kubernetes manifest information, as well as the pickup of the culprit L4 stream that I can download and then open Wireshark to see the actual L4 stream. As you can see, by the way, the difference between Wireshark and KubeShark, in Wireshark you see the IPs, right? So it doesn't really make sense who's talking to whom, but there's a lot of information that is lurking inside the actual packets.
Now, one of the cool things about Wireshark and KubeShark is that they're open source. And so open source packages get used and burned all the time. I mean, let's be honest, we've all seen dead projects that don't do anything, and it's just life. One of the coolest things that happened to me this week, or last week, was that I was speaking at the AWS Public Sector Summit in Washington, D.C. And one of my friends came up from a company called Porsche and said, "Hey, I heard you were talking about KubeShark next week." And I said, "Yep." And she said, "Guess what? We actually use it in a DoD project right now," and then showed me her version of what they had actually done, and it's called CAST from a company named Porsche. And they've actually integrated KubeShark into their incident response plan that actually allows them to catch when OT devices send session tokens across different levels of Kubernetes. So they do OT, incident response, and really cool stuff there. Totally different sort of use case than we're talking about here, but the fact is that they were able to take it and use the APIs and the system itself to totally integrate into another system entirely, which I thought was pretty neat.
Cool. So that worked live. No need for the video. Where did that go? I was so... Here it is, yes. No. Here it is, we found it, yeah. Okay, couple of more use cases that A couple of more use cases that you can use KubeShark for is again service map, watching TLS traffic. The eBPF enables showing pre-encryption and post-encryption traffic. No need, to use keys, certificate, man in the middle, stuff like that. Forensics, if you want to automate, pickup of certain areas of your network, you can. And I think that's it for the live demo.
It is. So that's pretty much our talk. Hope you've enjoyed it so far. This is the question and answer section. If you have questions about KubeShark or you'd like to talk about incident response as it's going, that'd be great. We'd be happy to answer the questions for you. Questions? Or not? Yeah.
I think the question got deleted from Slack. I think it was something along the lines of, is there any difference between AKS and EKS, something along those lines?
So Azure Kubernetes versus Amazon Kubernetes.
In the context of your talk.
In the context of the talk, in the context of the talk, they're both cloud services and they both provide a Kubernetes cluster, yay. But as far as being able to detect the network traffic on either of them, it doesn't matter. The beautiful part about this is that it supersedes the ENI utilization in something like an AWS, so that regardless of the fact that you're only able to talk to 2 points, it actually goes ahead and pulls it from the Kubernetes cluster itself after all of that work has taken place effectively. So if we think about it in layers, not normal TCP layers, but rather the concept of when it's actually being utilized from just a raw impulse to actually utilized in the OS or in Kubernetes, it's actually happening inside of Kubernetes. So regardless of the different security layers, TLS, take your pick, all of it, it's just dumped, which is beautiful.
AKS, GKS is just another way to frustrate us with all these acronyms. But no real... In terms of KubeShark, there's complete support.
Thanks for the talk. So I guess the question I'm left with is scale and storage. Like, does this data just get deleted on a regular basis? Because I would have a hard time imagining this working with a humongous cluster.
You can do it with a humongous cluster. It does work with S3. Object storage is the ideal.
So scale with Kubernetes is the thing. It's the main thing. The way it works, it has a distributed pickup storage at the node level. So think of a buffer that you can define the size of. It can also be on a persistent volume or not. Right? So the default would be 200 megabytes. It can also go to 2 gigabytes, where all traffic is being captured there, and then it goes away, unless there is something interesting there, through the monitoring, through the detection, or because you're now looking at it, so you still have a couple of minutes to actually see what's going on in the cluster. Okay? And if something is of interest, you store into a pickup and upload the pickup into S3. That's kind of what you see on that slide.
If you collect VPC flow, is there any way you can integrate or do more correlation with the data, or?
So VPC flow logs are only going to give you the point-to-point the point-to-points. So if you have, let's say you have an 80-node cluster, humongous, right? You're going to get computer-to-computer discussions. You're going to know how big that discussion was, but you're really not going to know any more than just that. The reality is, in this situation specifically, there's no utilization. There's nothing that goes into that package that's actually helpful to you. So this allows you to get into that package and actually see the pieces parts. Because the reality is, If you have a very large cluster, you're going to get just a bunch
Yeah,
of junk.
that's what-
Thank you. Is this meant to be on demand, or do you want to like turn it on beforehand as a capability in one of the telemetries?
So as an IR geek, I would tell you that you need to do it beforehand. From the
Okay.
point of view, you need to get a binary ready and then utilize the binary. Don't curl into root, but really go ahead and do something more along the lines of, hey, this is what we're going to use, this is when we're going to use it. But no, you don't have to launch it before you're actually ready to use it. What he did in the demo was legit. It really takes about 20 seconds to implement and actually begin getting data out of. So as an incident response tool itself at large, it allows you as the incident responder to hit a button, get a capture, and pull it out before the attacker's actually able to get anything out of that tool that they would then utilize against you,
Gotcha. Thank you.
which is kind of awesome.
I just had a quick clarifying question based on that prior question with VPC flow logs. Are you saying that that integration would be like very difficult to do? Because I think there's some additional fields that you can add to VPC flow logs, which would be useful. Like how it went out to the internet. You wouldn't know that based on the.
That's fair.
stuff
You
inside
wouldn't
the cluster.
necessarily know the routing. I'll retract and give you the points on that one. You are correct. If I were to do it, I would have gotten there probably, but you're right. That would definitely be something you want. You would know from the packet where it came from. It would come from the cluster, and you would also know from the DNS poll in KubeShark where it was going to go long term. So you could still determine it, but you're right. It would be nice to know which VPC gateway it was going out of.
Okay, thanks.
Yeah,
Right.
You're right. It's there. I agree.
By the way, you can export logs into, let's say, Elastic or any other schema-free document storage, and then also the VPC log, and then correlate there, not necessarily in KubeShark. So that's also available.
Well, the little integration we did there will work in whatever you'd want to do too. So.
Cool. Great talk. Thank you very much. I had a quick question from like a process standpoint. Would you run KubeShark before, like you would isolate a Kubernetes cluster and run it where it's at right now, or would you isolate it and run it? I think you would run it where it's at.
Depends on the incident and how
Okay.
bad it is. Like if
Yeah.
we're talking about, let's pretend you're running a nuclear reactor, then most likely, yes, I would probably segment and then figure out what was going on inside the segment and evaluate from there. If you were running a large, take your pick of, not likely to be a nation state actor, I would probably just tell you to run it to begin with so you get an idea as to what the whole overview of the thing is. And to be fair, it also depends on the documentation and ability you have as the incident responder to know where you are and what you're looking at. If you work for AWS and you happen to be getting dropped into an incident and you're getting dropped in dark and you have no idea what's going on inside of that box, the first thing you're probably going to want to do is evaluate what is the actual network flow that I'm looking at right now so that I can then figure out where I need to go and what I need to segment. Because to be fair, most of the customers that I've dealt with don't have very good documentation.
Gotcha. No,
And this does give us the ability, and again, going all the way back to NISC in the first slide, this does give us the ability to look at that identify portion of a cybersecurity plan and get the pieces, parts that we need to know about.
cool. Thank you.
Another question from Slack. What would you say are the main differences between KubeShark and existing Kubernetes observability tooling like Cilium Hubble?
I would tell you ease of installation, but this is you.
First, so Cilium is a great tool, and it's mostly used for networking and segmentation, and that's his focus. It's much easier, I would say, to go deep with KubeShark. So I think it's kind of two different tools. Anyone that tried Hubble, it gives you the service map, it shows you things. It's a bit harder to deploy, and again, it's the main use case is a bit different.
Any other questions? All right. Thank you so much. We'll be back in about 9 minutes with the State of the Union.